Hey everybody, in today's video we'll be looking at problem 53, maximum subarray. Starting with understanding the problem, given an integer array nums, find the contiguous subarray, so containing at least one number, which has the largest sum and return its sum. A subarray is a contiguous part of an array. Looking at example 1, so we have this big long array, the output is 6, and the explanation is 4, -1, 2, 1, so that's located here. This creates the largest sum, which is 6. Example 2, a very simple example. 1 just outputs 1. And example 3, we have all these numbers, and if you just add them all up, they add up to 23. Looking at the constraints, we see that there's always going to be at least one number, and the value of each number is between -104 and 104. So we know for sure, because it's an array, that we need to do some form of iteration. So the general concepts around iteration are, I think there's basically 3. One pointer, where you just have one for loop, one loop going over each number. So I'll just exemplify each one. One pointer, we're just going over each one. We have 2 pointer, where maybe you're iterating between using 2 points, and they're somehow operating to try to get to some result. And sliding window, where the idea is you are collecting contiguous sums. So just off the top, that sounds exactly like what we're doing. See, if I just slide from 4 to 1, we get 6. So how can we go about implementing a solution for this? We want to get the largest contiguous subarray. So we would start with -2. It is, and if this is the only world we know, this would be the end result. It would just be -2. But there's more numbers, and I think the concept here to think about, if you think in terms of heuristics, let's say you have -2 and 1. So the sum of this is -1. But -2 is not helping us at all with finding the largest sum, especially considering that this 1 is positive. So if you do -2 and 1, if we kept the window at these two numbers, then the sum is -1. But if we just get rid of -2 and work only with 1, then the sum is 1. So the principle here is that if we are negative, we can just, if our running sum is negative, but the next number is positive, or even here, let's make this even more complicated. -2 and 5. -2. Actually, let's make this -5 and -2. So -5, if this is the only world we know, this is the largest sum. But then if you do -5 and -2, this comes out to -7. So whenever our running sum is negative, we just want to start over. Even -2 is larger than -7. So we do that, -2, and then we go to 1. 1 is better than -2, so we just start from scratch. -3. See, now we're at -2, and we can just, let's start from scratch again, starting with 4, because 4 is larger than -2. And so 3, in this case, we don't necessarily want to start again. We do want to keep track of our largest number. So we say largest is 4. We iterate next, -1. So even though this is smaller, we're still in positive field. So let's just, we see 3, we don't update largest. We go to 5. It's still not the largest, but we keep sliding this way. And then we go to 6, and this is now our new largest. We go to -5, becomes 1, and we go to -4, 5. So that's the concept around how we can get the largest contiguous subarray. So how do we translate that into code? So remember we just had this largest value. Let's keep with that. And I would say we start with -infinity just so that any number, no matter what, so even if it's negative 104, we can say, oh, negative 104 is bigger than negative infinity, so negative 104 would win. We could also make this negative 105 since the constraint is, oh, you know what? The number can actually be between negative 10 to the power of 4, 10 to the power of 4, so let's keep this at infinity. And let's also just keep a track of our running sum. So just like we have a running sum down here, we need to write one of those. And we'll start with negative infinity as well, just so that we can keep overriding it. So now we just need a simple loop for let num of nums if running sum is less than 0. So this is once again the case that we're at negative 104, and then we're at negative 2. We just want to start from scratch. So how do we do starting from scratch? We say running sum equals num. Correct that. Running sum equals sum. Else. So in this case, it's not. It's actually our running sum is actually greater than 0, greater or equals to. So we say running sum plus equals num, and we just want to just keep tracking if our running sum is greater than the largest number we have so far. And at the end of the day, we just return our largest. And let's see how that guy does. Example cases. And let's run this. And there you have it. And that's problem 53, maximum subarray. Thank you and catch you later.